So guys, thanks you for taking your time to listen to me. I today want to talk about secure our IoT system in the post of age of quantum computing. Just before I start, who has listened to the talk before from Jan? Because I think this was a very good introduction into quantum computing and the problem statement. Nobody, perfect. Okay, then I can just extend my presentation a little bit. Not just kidding, but basically it's just me. I'm part of Accenture in Germany. I'm part of Accenture over 10 years now already. I'm a family guy like you see, and we're traveling lots. So I'm married and have a son who's just in the first class in Munich. And that's basically what I'm doing in my private life. But then I have also a professional life, so I'm based in Munich in our GenAI studio in the Liquid Studios. I'm part of Liquid Studios, and we see ourselves like a small Gaelic village where we really have lots of opportunities and things what we can do. So just to the right, what you see is basically my desk. I'm working there on some AI machine for a German car vendor where we do the pre-development, for example. And on the other hand, you see to the lower left, our newly built GenAI studio where lots of clients come in. So we have lots of traction and basically are like a front door. This is basically my role within the company. That's what I do over the day. But in the night, when everyone is sleeping, I'm in my recording studio. So you can listen to my music and check out also my YouTube channel if you want. Just scan the QR codes in the videos. And then you know what I'm doing in the night while everyone else is sleeping. But that's not what I'm talking today about. Basically, today, I just want to give you a brief overview of IoT. I guess most of you people know what IoT is. But as well, the whole problem with its security and the constraints you have with like restricted and like small hardware. Head over to the post-quantum cryptography and what this is basically about, but also what kind of impact this will have with IoT, because it's going to be really bad in my opinion, but also there are solutions and transition strategies I just want to show up with, okay? Just to set the scene, I'm no expert, okay? I'm no PhD in computer, quantum computing, string theory or whatever. This is applied knowledge. I have my knowledge from YouTube videos and articles and just like media and everywhere where everyone can get some information, but I'm just very interested in, of course, and on the other hand, also in context of IoT, I want to give you a brief overview where we are, okay? So maybe just again, IoT, right? IoT, I guess most of you know, it's about things and basically like we all have these smartphones, right? We all maybe have cars already that are connected to the internet. It's basically sensors in different places, in industrial places, in consumer electronics, etc., everywhere more or less. But always it's about sensors, and they are always connected to the internet in some way, whatever that is, either directly or via proxy or anything. Yeah? So, for example, this is my house in my basement. Yeah? To the left you see the gas, so my heating system, just a counter. It's an ESP32 microcontroller taking the photos of the counter, digitalizing it, providing an API, and then via Home Assistant, I'm reading it, so therefore I am happy to read the status of my gas bill, for example. Or to the right, you see my electricity counter. So I touched an infrared device. You can buy these on eBay, by the way. It's super cheap. There's also an ESP chip in there, and it just reads the state and sends this to my Home Assistant system, and so I can control how much energy consumption I have, for example, yeah. Then here to the left, you see also some other Raspberry Pis. I'm doing OpenVPN and Node-RED and all these things because I like it. And I'm doing some fancy home automation. And on the other hand, you're seeing this is the house from my parents where everything has been synced via VPN. So I'm a backup nerd as well. And this is just also, yeah, I just don't do this in my professional life, but also privately. Yeah, this is where I'm coming from. But just to extend the scene, basically IoT, it's about monitoring. You always want to know maybe a state of the system or like the electricity bill. Is your system still alive? So many things. On the other hand, it's also about automation because especially when you're doing home automation, you want to automate things, for example, that the light turns on automatically or maybe turns off automatically. Or also you want to do the analysis. I just mentioned the power consumption, right? And you have, for example, smart home IoT, industrial machines, OT technology, IT, OT, etc. But in the end, they all have in common it's connected to the cloud, or cloud computing, or some internet, whatever that is. Plus, the new term is edge computing, yeah? And there also we're talking about devices that are on the edge. It's not just old on-prem hardware, but really going into the field of IoT. So, what's important when we talk about IoT and security, right? There are some things we have to consider. For example, on the one hand, the user might, or the system might, like a technical user might authenticate itself, himself, herself, whatever, and basically use the service, right? We some kind of also have the desire to have a kind of data integrity, yeah? So that we say everything works, and it basically also has a kind of uptime, for example. The data is available and also in a safe state, so that it's not corrupted, for example, right? We want to be confident that actually we get the true data and not that there's some fake data or some malfunctioning system and this is just providing any data, right? We want to have, of course, high availability, means like availability as much as possible, but of course also to a certain amount of cost, whatever that is. With IoT, you also have to deal with secure software and firmware updates. So updates come out and new protocols, maybe new software, whatever features come in. So you want to be able to do over-the-air updates, for example. Yeah. And if you look more to the scalability, more to the industrial context, it's about scalability. You want to scale up your system. You want to be able to install dozens or if not thousands of systems. And then you have such unsexy topics like software lifecycle management, user management, authentication management, hardware lifecycle, for example. All these things come into place when it comes to scalability. And of course, you will need kind of device and network level security. So you can't just go in like in my basement, in my house and just steal the things, right? That shouldn't work or you should avoid such things, okay? So that's not the reality. So their IoT systems, in my opinion, are really a pain because it's not just like a web server that you can easily update it and then be happy that you have an updated version. But very often you physically have to go there, right? Maybe it's a camera on the tree, or maybe in your gas station in the utility environment, you have to climb up somewhere, and because there's an edge compute device, you might have to update. So there are problems. And usually the problem starts as well with the devices, because these devices, they are low power consumption devices. So you always have resource constraints, whether it's energy or maybe capacity, how you can store, or performance, etc. Also, the large attack surface is quite clear. If you have devices in the field that you're not always maybe secure in a data center or anywhere else. There are also physical problems you have just because people can see these devices and also have different kinds of possibilities to access these devices. And then the amount of devices and the variations of devices is a problem. Like if you're in a company or a business and these devices, you grow them and you have maybe a new charge of devices, they also can change. So it's not always quite homogeneous, but you have different devices available. And then, of course, there's this kind of IoT jungle. So you see to the right with Gen AI, I always try to do kind of pictures that fit to the topic I'm talking about. The standardization of IoT, it's just a mess. Like there is no standards, there's nobody else, nobody who says what is an embedded system, what is an MCU, what is an edge device, for example. That's really not really clear. And plus, the whole encryption topic will come in a second. Very often you have hard-coded keys into the source code, for example, and then you might not have any over-the-air updates. Or, for example, also physical security. Maybe everything is just unencrypted on an SD card, like on a Raspberry Pi, and you just plug this in, and you can just plug out the SD card and read the content. That's just normal, right? And also a topic I think that's very important to talk about. No one is talking about the lifespan of devices. Like you buy a car and everyone expects a kind of lifespan, right? So life cycle management. But if you buy, I don't know, a router in your electronics store around the corner, no one tells you, will it work in a year or 3 years, 10 years? Do you get updates? And what happens after this time? Like if you have an expiry date, what happens after that? So no one puts an expiry date on these devices. I think this is a problem. And at least also for consumer electronics, it's not really clear because no one wants to clarify that. So here, from my Home Assistant, basically the web interface, and you see there's no certificate in place, and it's just HTTP, so Chrome is warning me to use my own Home Assistant, and the whole traffic is basically unencrypted in my own network. But that's just the reality, and it's not getting better with other devices, because this whole problem with exchanging certificates is just a problem. It's just a mess. And this is just also what Jan talked about. Business, they have thousands of certificates maybe in place, and exchanging them is really a bad job, and it's not really fun. So It's just getting worse, right? So I just set the scene where we are. There are, of course, different attacks you can think of. DOS attacks, I think most of you know. So if you like have many maybe API requests against the device, man-in-the-middle attacks. So you just be in between and, for example, have a router or anything else, a device that basically records what you're doing. Ransomware. Physical attacks, like I said, we're talking about physical devices, right? And firmware attacks, most of these IoT devices, they're not checking if the firmware is from a trustful source, for example. You can just boot up anything, yeah? Or like side channel attacks is also an interesting topic. Like if you have let's say, Arduino board or some other device, and basically you control the electricity, it might boot up or not, and then you get maybe devices in a certain state, for example, for maintenance reason or for firmware upgrade. And so there are many things you have to consider, and it's really more difficult than a web server that is on a physical server in the data center. So having all this said, basically, I guess I set the scene where we are, and so I thought, okay, let's talk about some real-world examples, and I created these nice logos for some very attacks that have happened. So does anybody of you know these topics like Mirai, botnet, or Stuxnet hack, for example, or so one guy, 2, 3, maybe just set the scene. So Mirai botnet, for example, this was, I think, in 2016, and some people took over hundreds, thousands, if not millions of consumer electronics like routers, and were using this for a botnet just because they could. For me, the most crazy one was Stuxnet, because it was in 2010, and I believe they started in 2010. It was basically an attack against industrial control systems from Siemens, and what they managed to do is, in Iran, you have these plutonium machines that create this plutonium, and they were distracted. I think they were turning faster than they should, but they were offline. So somehow somebody managed to get an updated firmware or system or control software on these devices that were offline via some Windows computers, via some flash drives, and it was quite clear who was in attack, which was Iran. And so people say that because of this, they were thrown away for years with their atomic program, if they ever have one. So one might ask himself, herself, where this is coming from, but seems like somebody invested a lot of time and effort and resources into this one attack quite specifically. And then last but not least, there's also this Grand Cherokee Land Rover attack, where security scientists showed up that they can remotely log into the Jeeps, the cars, and control the devices. And they can take over the cameras and everything what's in there. So it's not just some Raspberry Pis that are hacked or consumer electronics, it's cars. And these cars are on the street. So I think this is crazy. And the list could go on and on. So now, I guess your motivation is quite low, and I set the scene how bad everything is, and now I come in with quantum computing. Can anybody get an idea why I want to merge quantum computing now with IoT devices? Do you have any clue? So Jan in the talk before was talking about that it is already that's a fact that intelligence services and many others are already harvesting data, they store away everything what they can get. And maybe it's encrypted so far, but also with the age of quantum computing or post-quantum computing, you could decrypt the data. And someone came up with the question who should bother if the data is already 5 years old, right? But my answer for that one would be, if you're now able to store or get the data from now, you can have a history of things. For example, my driving behavior, my energy consumption, or if I have a business, right? What about the data that has happened 10 years ago or 20 years ago? I think this tells stories, and there are people out there or countries who are able and invest these resources and store all this data what they can get. So it's the same with IoT data. If you stream from an edge device to the cloud, there are some routers in between, some systems that basically could record the data what you have. But maybe just a short overview again, quantum computing, what this is about, I'm not sure. Or are you familiar with quantum computing at all? Because I think it's quite cutting edge technology or topic. Okay, maybe just in a nutshell, and I will go through this fast. You have bits and qubits. Yeah, bits is either 1 or 0, but qubits basically can store multiple states. And just when you read them, they either say 0 or 1, but they can have multiple. And because of that one, you're able to do crazy complex operations with these quantums, with these qubits, because they can represent multiple states. Yeah. And you also have this term of entanglement. You might have heard this. So you have a quantum maybe here, but there's another one in this universe, and they are linked together. And it doesn't really matter how far they are away, which is, I think, quite crazy. And also, you have quantum gates in quantum computing, so gates like AND, OR, NOR, NOT, etc. This is how we build computers, chips on low level. You also have these mechanisms with quantum computing. But because of that one, you basically can create algorithms that work much more efficient and much faster in a certain state, even though quantum computers are not faster than normal computers. So if you think of like gigahertz or MIPS or any of these terms, they're not really faster, but they're very specialized or can be very specialized for some very specific problems or algorithms or things you can do with these machines. For example, I mentioned here Shor's algorithm. I will talk about this in a second, or Grover's algorithm. This is then, for example, when it comes to the routing problem. When it comes to for example, Google Maps, you want to go from A to B, or maybe you want to check how a postal package should travel around. Those problems with a quantum computer, if we would have one, you could solve pretty fast. So there are applications, especially in the research and in the research of different topics, where they see some potential for this one. However, the current state is not just there. Outside, I'm not sure if you have seen this, there's this one company with this, I think they have 1 or 2 qubits. And the problem with these qubits is that they have this whole decoherence. So you have to, like, if there is some noise, and you cannot just easily operate them. And this is such a big problem that I think up to now, what was the record? I think 20 qubits or so. I think Google had a few years back. But we are talking about thousands or thousands of qubits you would need to basically crack a current RSA encrypted code. But once we are there with Shor's algorithm, it would basically show, so I tried here my iPad, by the way, just to visualize what I'm talking about. So if you try to decrypt some RSA encrypted code, yeah, you will basically have the problem of exponentially growth. This is a logarithmic scale, by the way, but exponentially growth of the problem and time and resources you have to invest to actually crack it by brute force, for example. But on the other hand, if you do the same thing with Shor's algorithm on a quantum computer, you would have the problem just much faster being solved. That's the problem. This is where we are currently. So it has an impact on RSA and ECC, so this elliptic curve encryption. But that's currently what the problem is, and this is why governments and companies already store as much data as they can and try to basically make some usage out of it, okay? But of course, there are some solutions for this problem, and this is called PQC, or post-quantum cryptography. And as said, I'm not an expert on this topic, but I just want to come up with, there are some solutions in some topics, because very smart people make up their thoughts on this topic and how they basically could solve this problem once quantum computers are there. And even though if it's in 20 or 30 years, you already should react now, and this is my message, by the way, you already should react now and basically think of these PQC algorithms and think of, for example, about your over-the-air update mechanism or your web server, how you're able to update the system so that you can just exchange the encryption method, for example. So what are PQC algorithms? So PQC algorithms basically just resist quantum computer attacks. It's that simple. And they basically secure data against quantum computers, and right now we try to solve in a mathematical way that basically they are hard to hack on a quantum computer. So they should resist as well running on a quantum computer, and that we can just encrypt our data safely. And of course, we want to have a kind of long-term digital security capability, so that we know when we store our data or we implement these algorithms that they are also safe for the future, right? So just in a nutshell, think about classical cryptography and post-quantum cryptography. On the one hand, classical one can be efficiently solved by quantum computers, and of course, post-quantum, we try to solve this kind of problem. And just for the sake of completeness, I will not jump here into this topic. So there are some solutions there, like lattice-based cryptography, hash-based cryptography, etc. Just for the sake of completeness, you have this here in the list. I will not talk about this, but of course you understand that this has an impact on IoT systems at all. Let me just jump over this slide here. I think I talked enough about this. Just coming again back in a nutshell, where we are and what you have to consider. I just picked some topics here because there are just too many. But if you think about the energy consumption or just hardware requirements and also key management, those topics are problems already for web servers. But having this in mind for hardware really is a problem, but we can act now already. Yeah? Also consider such things if you think about cost and scalability, and also think about legacy systems. Yeah? If you're a business, I guess most of you are not, yeah, because you might be students, etc. But what about the legacy systems? It's really hard to update them, but we have this problem. And also for PQC algorithms, you might need some larger key sizes, so you also have to think, how do you store these ones? Or what about hardware acceleration, for example? And of course, there are uncertain threats in the future. How do we get our systems ready for such things? Yeah, and I know it's quite dry, this topic, so I just try to prompt this with Midjourney, and this is basically what the GenAI tries to solve me with, so it doesn't really help me, but it created some nice pictures, and I just wanted to show you these pictures here. But at least I tried to do so, yeah. So I think GenAI is not the solution for everything, but we really have some problems to be solved, but of course it can help us quite nicely. So let me help you to just think beyond and give you a small outlook what needs to be done, okay? Like, I just gave you a summary of existing IoT problems, what we are, and we won't solve this today, but on the other hand, we can already think of a transition for cryptography that just doesn't work. And the point here is, of course, like Jan presented in his slide before, we are right now here in the current time, but in the future there might be quantum computers. How much time do we have now to react, and how much time does it take us to implement these solutions? And this is basically the bet for the future. This is what we have to think about. So maybe some solutions are all these algorithms I'm talking about. Currently they're in optimization. And all these algorithms, they are already going to be optimized for energy constraints, for example, or how can we use hardware acceleration to actually get these things on IoT devices. For example, think of FPGA and ASIC chips. So like with some Intel Xeon CPUs, you have this already. You have you're able via software to control some gates, etc., in the hardware state. So you can put hardware acceleration with software on the machine. This is basically how you can just store it for yourself. But we need hardware acceleration for some things. You also have to consider more memory management techniques, because IoT devices by definition always have lots of memory constraints. The same with energy optimization. And also think about some hybrid modes, like maybe some cryptographic work you put to the cloud, or maybe not, but in the rise of edge computing, you're able to solve such things with strategies, but it's getting not easier, yeah? And basically the same with think of external resources, like you maybe can have some load in the cloud or near edge or on the edge device itself. So now you think like, oh God, what happens? Where are we? What's happening? And this is just a brief overview of what should happen, yeah? So you have some academic research, you might have heard of NIST, for example, so they try already to standardize this process of how do we mathematically prove that an algorithm basically is safe and we can use, so people are working on this. But another problem is, of course, the industry adoption. So how do we make sure that this stuff is basically really used in the industry, yeah? And not that we basically using old MD5 algorithms or anything that maybe doesn't really work in the future. And of course, we need global standards and initiatives for our IoT systems. Like I'm saying, I want to have a party in Europe that votes for expiry dates for IoT devices. Like if I go there and buy my router or buy my car, there must be an expiry date where they claim they will not have updates beyond 5 years, for example. And of course, we have to consider any future developments, because the world does not stop spinning there and things go on and beyond. But those are the things we have to consider. And of course, think like about maybe some, what else can we do? Just stay informed on standards, right? basically think of any backward compatibility so that we are able to update our devices, what we deploy right now, even though quantum computers are not there. Over-the-air updates, so many IoT devices you're not able to do over-the-air updates. You have to put in an SD card, for example, and or put in a cable and push a button, and it's just complicated. And of course, we have to make people aware of this whole topic. So I hope at least a little bit I could make you aware of this whole topic, yeah. And I think you are able to act now. If you're interested into IoT or hardware at all, and that's basically what I wanted to present to you. And thank you. So thank you for your time.
Thank you, André. We have several questions. So the first one, do you use Node-RED for your Home Assistant or any other tool, or which tool?
Sorry, what am I using? I didn't.
Node-RED.
Yes, yeah. So we are not. I think the nice thing, and also by the way, in my work, I'm using Node-RED a lot. The nice thing of Node-RED is you can pretty easy implement things and combine them together. You can integrate things quite easy. And I really enjoy this one, although it's not the solution for everything. For example, I mentioned Home Assistant, but I'm also using Home Assistant in the office for certain tasks, not just for automation, but it's pretty easy to just spin up, for example, an MQTT message broker or have an API available and connect it to the internet or anything. But the same with Node-RED. So Node-RED for me is always, we have different things in APIs and MQTT messaging system. We just go there with Node-RED. So I think it's a really nice system, and it's already out there for quite a while, so yes.
Thank you. So for now, we will forecast something. Do you think, let's say in our life, next 50 years, will be computer and PCs which will break today's cryptography?
For sure, you can be for sure. It's, I think, clear. There will be systems that can break our current system.
Okay, so do you think that expiration dates will affect waste, like electronic waste? What to do about it?
Well, if you know already that your device will expire in a few years, right, there's no guarantee that it will not work, but just you know that there is a risk, right? So you can manage and deal with that, that's the point. But on the other hand, we know, okay, there is electronic waste and devices break, and we have to think, okay, how do we proceed with that so that we actually can use these resources that are in there, right? It's not basically to set an expiry date. But on the other hand, let's say I have, I don't know, a smartphone and I get no updates anymore and I have a problem and I have to act fast. I think this problem is bigger than I know, than if I would know, okay, the device is only working for a year, for example, and I have this 1 year to react and get a new one or a new router. That's my opinion.
Okay, so far it was the last question. I think the topic that you raised still has a lot of questions to ask, and people still need to think about this. I would like to thank you for visiting us.
Thank you for having me.
For sharing also your Spotify. I will listen to. Thank you.